Okay, go ahead and throw your name on your note card because you'll turn it in with your test, and that way if you have to finish or do corrections, we can get it back to you. And that way we know who's whose. And if you fall on the ground, you know who's whose. All right, we organized the front of this note card into the 3 different methods of finding zeros. So method 1 was solving, method 2 was factoring, and method 3 was the quadratic formula. Then we also squeezed 6.5, which was axis of symmetry and vertex on here. So we are going to go through, we've got 1, 2, 1 examples of each thing. There are some problems that we didn't put on. No, we put every type of solving, every type of factoring. We just didn't put a difference of squares factoring. That's the only thing that's not an example that you could do. On the test, the front page of the test has 6 problems, and you are allowed to choose whichever method you want. So only some of them you can solve. But then from there, you can choose factoring and quadratic formula. You could do quadratic formula on all 6 of them. I don't care, as long as you do it correctly and show your work. Okay, first method we did was solving. Solving is the only one that you can only use sometimes. You can only use it if b equals 0. So in this problem, since b equals 0, it's just an a and a c term, we can set this equal to 0 and just start solving. So we will add 121 to both sides. We'll get 36x squared equals 121. We can divide by 36. And we will get x squared equals 121 over 36. And then to get rid of that square, we will take the square root of both sides of the equation. So we will square root x squared, and we'll square root all of this. When we do that square root of 121 over 36, we want to do them separately. What's the square root of 121? Okay, and what's the square root of 6? Or 36, sorry. 6. I said the answer instead of saying the thing. So we will have 2 answers. They will be 11 over 6, and they will be negative 11 over 6. So just a reminder, anytime you have a square root, you have a positive and a negative version at the end there. Okay. Any questions about solving? Okay. The next method we did was factoring. We have 2 factoring examples on here. The difference between the 2 factoring and what you have to do depends on whether a equals 1 or a is greater than 1. So if you want to put a little note of that, a equals 1, a is greater than 1. That changes how much work you have to do. So for this first one, where a equals 1, we just have to find the 2 numbers that fill in our little x, and then we're good to go. So I'm going to make my little x. We are trying to multiply to c, so we're trying to multiply to 18. And we are trying to add to b, so we're trying to add to 9. If you need to make a little note that says multiply to c, add to b, so you remember what your goal is, make a little note. This is a note card for you to note down everything that you need. Okay. What numbers multiply together to be 18, add to 9? 6 and 3, awesome. I'm going to put 3 and 6 just because I like to always put the little one first. So with this method of factoring, you do not have to do the factoring by grouping, the splitting the middle term. You are just done once you find that 3 and 6. Well, you got to keep going, but you don't have to do any more work. So we are going to write our factored form as x plus 3 times x plus 6. Okay, then a reminder of what happens next. Once we factor, we set each factor equal to 0. So now we're going to have x plus 3 equals 0 and x plus 6 equals 0. You can write down this step if you want. You do not have to on your test because we know you can do these in your head. Because right here when we go solve, we'll subtract 3 from both sides. We will get a 0 at negative 3. This one will subtract 6 on both sides. We'll get a 0 at -6. So that's called the zero product property, is us ultimately finding the zeros by setting each factor equal to 0. Okay. Any questions on that factoring one? All right. The next factoring one, I'm going to draw a line. I should have put a line on here. The next factoring one, a is greater than 1. So when a is greater than 1, we have a little bit of extra work to do, which is why I gave us a little bit of extra space. So a is greater than 1. We are trying to find two numbers that multiply together to be AC and add together to be B. So if you need to put down a note of that, we're not just multiplying to C, we're multiplying to the product of A and C this time around. All right, so I'm going to make a little magic X. My AC in this problem is 2 times 15, which is 30. I am trying to add to -11. That's my B. So going through my numbers that multiply to 30 are 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, 5 and 6. 5 plus 6 is 11. I can make them both negative. -5 plus -6 is -11, and it'll still multiply to that positive. So my two numbers I'm going to use are -5 and -6. Okay. Any questions about that? Okay. We are going to take that -11x then, and we are going to split it. So we'll keep our 2x squared the same. We're going to split our -11x into -5x minus 6x, and then we'll keep our plus 15. Okay. From here, we can factor by grouping. So out of 2x squared and minus 5x, we can't divide 2 and -5 by anything, but we can pull out an x. So we pull out an x. That leaves behind the 2 and the other x. And then from the -5, when we pull out the x, it leaves just the -5. Okay. Then for -6x plus 15, we can divide 6 and 15 both by 3. And since it's currently minus plus and we want to leave behind plus minus, we're going to pull out a -3. So we'll divide a -3 out here. -6x divided by -3 is positive 2x. And 15 divided by -3 is -5. So then what I have left behind matches. Okay, we are going to write our factored form. So our factored form is going to be 2x minus 5 and x minus 3. So 2x minus 5 was our factor that matches, and then the x and the minus 3 come from here and here. Okay, and then we will set each of these factors equal to 0. So 2x minus 5 equals 0, and x minus 3 equals 0. I left more space on this one. Some of us, a few of us are able to do these in our head. A lot of us aren't. These ones, a lot of us are able to do in our head. But when it's 2 steps, sometimes getting the positives and negatives and the fractions, it's helpful to write it out. So let's write out this one. We'll add 5 to both sides. We'll have 2x equals 5. And we'll divide by 2. So one of our zeros is going to be 5 halves. The other one, we'll add 3 to both sides. Our other 0 is going to be positive 3. Any questions at the moment? Okay, I'm going to tell you guys that you can get through your whole test without that. You could choose to do quadratic formula instead of that method for the entire test and still get 100%. Come grab a note card, any color, over here. That's what we're working on right now. Hey, so speaking of quadratic formula, you do have to know how to do the quadratic formula. There's a few problems on the test where we ask you to find the discriminant and then use the quadratic formula if there are solutions. So for those ones, you're going to have to know how to do the quadratic formula because you have to use the discriminant to find the number of solutions, and then from there you should just keep going. So moving over here, this is the quadratic formula. We put it on the note card for you so you don't have to memorize it. Our discriminant is just the part underneath the square root, which is b squared minus 4ac. Okay, your discriminant determines how many solutions you have. So you have no solutions if your discriminant is negative. You have one solution if your discriminant is equal to 0. And you have two solutions if your discriminant is positive. So on your test, there is a section where we ask you to find the discriminant and then find the solutions if there are any. So sometimes you'll find the discriminant and then you'll stop because there's no solutions. Sometimes you'll find the discriminant and you'll keep going to get one solution. Sometimes you'll find the discriminant and you'll keep going to get two solutions. It just depends on what the discriminant is. All right, I could not fit A equals B equals C equals lines on here, but they are on the test. So on this problem, my A is 11, my A is 6, my B is 11, my C is -7. So we're going to go through and we're going to start with our discriminant. So we'll do b squared minus 4ac. So that'll be 11 squared minus 4 times my A value 6 times my C value is -7. And we can just throw that in a calculator. I don't know what that is off the top of my head. It's a Monday. 11 squared minus 4 times 6 times -7. I get 289 on this for my discriminant. Since 289 is positive, that means there's two solutions. So equals 289. There are two solutions. Okay. Any questions about the discriminant part? Right, so then we got to plug in to the rest of our equation now that we have a discriminant, and yes, that is a perfect square at 17. So we will do x equals -b, so that'll be -11, plus or minus the square root of b squared minus 4ac, which is already 289, we know that, all over 2a, which is going to be 2 times 6. Right. Then we can take the square root of 289. So now we have -11 plus or minus square root of 289. Second square root 289 is 17. And then 2 times 6 on the bottom is 12. Any questions there? Okay. So then we will split this and we will solve our two different fractions. So we've got -11 plus 17 over 12 that will simplify out. We have -11 minus 17 over 12 that we will simplify out. Okay, -11 plus 17 is 6. So I end up for this one with 6 over 12. What fraction is 6 over 12 the same as? 1/2. 6 is half of 12. So we can divide the top and bottom both by 6. And we get 1/2 as one of our answers. For my other fraction, negative 11 minus 17 is negative 28. So I've got negative 28 over 12. This one's weirder. We can divide 28 and 12 both by 4. So 28 divided by 4 is 7. So I've got negative 7 on top. And then 12 divided by 4 is 3. So I've got negative 7 thirds. And I know it's a tight squeeze, but it's a note card. Trying to fit as much on as we can. Right. Any questions about the methods of finding zeros? Okay. Technically, you can get by on the test if you know the quadratic formula, because you could always use the quadratic formula. I'm like 98% sure there is nowhere on the test that we require you to factor or require you to solve. Oh, I think on the graphing 6.6 ones, we ask you to factor like this. So if you understand this and this, you have enough. But mainly it's just make sure you understand the quadratic formula. That is much more of a priority than this method of factoring, because this is going to help you more in the future than this is. Okay, any questions at the moment? Right, we are going to look at 6.5 real quick. We didn't actually put an example of 6.5 because you do 6.5 on the back when we graph. So right here, we just put down, hey, here's standard form. This is where you get your A, B, and C. Hey, here's the formula for axis of symmetry. It's negative B over 2A. Once you get that X value, you plug it in. This is the only little note that we felt like we needed. If A is positive, your graph opens up. If A is negative, your graph opens down. And if you want to draw my magic little smiley face, opening up is going to look like that. Opening down is going to look like that. I did not include on there max and minimum, but if you look at this graph has a minimum, this graph has a maximum. So if you feel like you need to add that in, you are welcome to add that in. Okay. Any questions at the moment? Okay. We will get done with your note card. We will get you your reviews. You're not going to have much time at all to work on your reviews, but I want to give them to you today in case you're gone on Wednesday. Hey, last two things is our big sections of graphing, and it's organized horizontally just because that's the way it fit the best. So in 6.6, we graphed by finding the axis of symmetry, vertex, zeros, and y-intercept. In 6.7, we did the little thing with the table. So let's work on this. For 6.6, when we are graphing and A equals 1, we find our axis of symmetry and vertex. So let's do that first. We've got A is 1, B is negative 6, and C is 5. To find our axis of symmetry, we are doing negative B over 2A. In this problem, my B value is negative 6. So I've got a negative from the equation and a negative from the 6. So I've got double negative on my 6. And on the bottom, 2A is 2 times 1. Okay. Negative 6 is positive 6. And on the bottom, 2 times 1 is 2. And then 6 divided by 2 is 3. Okay, so our axis of symmetry is 3. And that is also the X value of our vertex. Okay, to find the rest of our vertex, we would plug that 3 in. So we've got x squared minus 6x plus 5. So we're going to do 3 squared minus 6 times 3 plus 5. I'll go ahead and scoot over. So it would be 3 squared minus 6 times 3 plus 5. I get negative 4. So my vertex is at 3, negative 4. So from there, I can go ahead and graph both my axis of symmetry. I like to graph as I go. Some people like to wait until the end. Completely up to you. I'm going to graph right now, though. So I'm going to graph my axis of symmetry. I'm going to graph my vertex at 3, -4. It's right there. I know the graphs are small. They will not be this small on your test. But again, to fit it on a note card, we had to make it small. Hey, any questions about that? Right. From there, we are going to go ahead and factor now. So to find our zeros, we are factoring. That is factoring like we did in 5.6 or 5.7. And we are finding our zeros like we did in 6.1 by using the zero product property. So for this problem here, we are trying to find two numbers that multiply to 5 and add to -6. The only numbers that multiply to 5 are 1 and 5. 5 is a prime number, so it's just 1 in itself. And how we make them add to -6 is make them both negative. So -1, -5. So my factored form is going to be x minus 1 and x minus 5. And then my zeros will be +1 and +5. That's the opposites. So over here on my graph, I can graph those at +1 and +5. Okay. And then the last thing is finding our y-intercept. So to find our y-intercept, we plug in 0 for x. Well, if we plug in 0 for x, it's just going to be 0 squared minus 6 times 0, so it's just going to be 0, 0. Your y-intercept on these 6.6 problems is always just going to be c. So we know that it's always just going to be our c value, which is 5. If you would like to write in, plugging in 0 for x, so you know how we got that, you can. I would either write this down so you can do it in the future, or write this down so that you know it's always just c. Okay. So the last thing that we can do is plot that point at 0, 5. So 0 over 5 up, right there. And then we reflect that so that we are symmetrical. So it's currently 3 to the left of the axis of symmetry. We're going to put another point 3 to the right of the axis of symmetry. Okay. Any questions for the good of the cause? We'll connect this into a nice little U then. And be done. Okay. Change of plans. This note card's taking much longer than I thought it would. We're not going to do, we're not even going to start the review today. I'll just give them to you guys on Wednesday. That way you don't even have to worry about them. Give you guys a little bit of breathing time at the end of class today. And if you have anything that needs to be checked, I can do that too. Hey, questions about 6.6? Okay. We have one last question then. This is 6.7. This is what you guys did on Friday. Based on this stack of assignments, it looks like we did well with that. So for 6.7, we find our axis of symmetry still. So I've got my A equals 4, B equals 16, and my C equals 7. So I'm still going to do the axis of symmetry part. So x equals negative B over 2A. So that's going to be negative 16 over 2 times 4. So I'll be negative 16 over 8. And negative 16 divided by 8 is negative 2. Any questions about that negative 2? Okay. From there, we put that negative 2 in the middle of our table. as our middle x value. And then we want the two values lower than that. So it's a little confusing when you're on the negative side, because lower than -2 would be even more negative. So -3 and -4 should go above. These are lower because we always go from least to greatest. And then greater than -2 is going to be -1 and 0. Okay, and then this takes a hot second and a half to fill out our table. But what we are doing when we fill out our table is we are taking this -4 and plugging it in for x. So it's going to be 4 times -4 squared plus 16 times -4 plus 7. Then you guys can continue to fill out your table, and then I'll remind you, I know you guys saw it in the video, but I'll remind you and show you again how you can use your calculator and not have to type it in every single time. So plugging in -3, it would be 4 times -3 squared plus 16 times -3 plus 7. I'm going to fill out the rest of my table and not narrate it out loud. We're just replacing the x value with the x value we want to plug in. All right. Any questions on filling out the table? Okay. If you don't remember from Friday how to plug it in, I would pause filling out the table. I'll leave this up here and you can get it back in a second. And I would pay attention to how to plug it into the calculator. So 4 open parentheses -4 squared plus 16 times -4 plus 7. So once I get 1 plugged in the calculator, I can get my solution to that. It's 7. But then I want to not clear my calculator. I can either hit second enter, or I can scroll up and hit enter. And then I can just scroll over, and I can replace all my -4s with -3s. Oops. My -4s with -3s. There we go. You just hover over the -4, turn it into a -3. I can keep doing that without having to type it all in again and again. So my next one I get is -5. Okay. I'm going to go plug in -2. So I'm going to up arrow and hit enter, scroll over, replace my -3s with -2s. Boop. I get -9. Scroll up, hit enter, replace my -2s with -1s. Hit enter, I get -5. And then this last one, I need 0, so I don't need the negative anymore. So if I scroll over to where the negative is, I can delete the negative. So the delete button's right there, DEL. Delete the negative, replace it with a 0. Delete the negative, replace it with a 0. And I get, oh my goodness. I get 7. Okay. Any questions for plugging into the calculator? I know some of us still need to get caught up from Friday. So those people might have some questions, but any questions, because I know I wasn't here to answer them. All right, we can go ahead and graph this then. So we started 0, 0. We're graphing these ordered pairs. So -4, 7. So left 4, up 7. -3, -5 is going to be left 3, down 5. I think I went 1 too many. And of course, I don't have any white out over here. That doesn't look good because, like, my paper's not white, it's yellow. -2, -9 is left 2, down 9. -1, -5, so left 1, down 5. Do that correctly this time. And then 0, 7 is over 0, up 7. Okay, and then we can connect those all into a beautiful, tall, skinny U. Okay, questions at the moment for the good of the cause. I'm going to stop this video then.